All right, the last group of organic molecules we're going to look at today are the cyclic molecules. Now, these aren't technically their own family, but because of their cyclic nature, meaning ring-shaped, it does change a little bit about how we name these molecules. So, for example, here, you can see here there's a 5-carbon molecule in a ring, and it forms kind of a pentagon shape because of the 5 carbons. Their general formulas are different than our normal alkanes, alkenes, or alkynes. You'll notice that they're all 2 lower. So the alkanes used to be 2n plus 2, the cycloalkanes are 2n, and the alkenes are 2n minus 2, and the cycloalkynes are 2n minus 4. And the reason being, just like we had to drop 2 hydrogens in order to make the double bond, we also have to drop another 2 hydrogens to take that straight molecule and be able to connect the 2 ends together to form that ring structure. So they'll always be 2 less than their straight chain normal ones. So just remember, as soon as it's a cyclo, its general formula is going to be 2 less than you would expect if it was straight. Okay? And cycloalkanes are very common. Cycloalkenes are very common. The alkynes are not as common. You can, because of the stress of the triple bond, you really only get cycloalkynes in 8 carbons or higher. So cyclooctine, nonine, decyne, those would only be they'd be the only ones you'd be expected to name in Chem 30 because we only go up to 10 carbons in the parent molecule. All right, so typically they're represented by geometric shapes, like I said. So this one, for example, is a triangle. If it was 4, a butte, it would be a square. You kind of get the idea. And because these are ring structures, it changes a little bit about how we're going to name, or at least number, the parent, because there's no start and there's no end. I can kind of start wherever I want. Now in this case, it doesn't matter. That's my parent, and there are no branches, so I don't need to number it. So this is a prop. It's all single bonds between the carbons, so it's a propane. And because it forms a ring, I add on the cyclo prefix. So this is cyclopropane. So not a big difference, just adding in the cyclo prefix to tell us that it's a ring shape. All right, let's move on to the next one. Okay, again, no branching, so it's all parent. It's a 8-carbon ring, so it's an oct. It has a triple bond, so it's an octine, and it's a ring, so it's a cyclooctine. I don't have to number where that triple bond is though, but because it's a ring, there is no start, there's no beginning. I can number it wherever I want. And so since I can number from wherever I want, if there's no branching, it's unnecessary to add in the numbers. All right, now let's add in some branching and we'll show you how this works. So I still have my parent. It's a cyclo, because it's a ring. It's a pent, because it's 5. And it's an ane, because all the bonds in it are carbon-carbon single bonds. Now I have a branch here that's a single carbon branch. So this is a methyl cyclopentane. Because there's only one branch, I don't have to number it, because I would just make that carbon 1, because I can start wherever I want. And so since I can start wherever I want, I don't really need to say 1. Again, if you did it though, I wouldn't mark you wrong. It's just unnecessary. That changes though when we move from 1 branch into 2. So let's look at a few more of these. If I've got this molecule, for example, and we look at our parent, I have a cyclo because it's a ring, pent because it's 5 carbons, and it has a double bond, so it's a pentene. Now, I don't have to number where the ene is, like I said, because I would definitely, it's the functional group, it's the most important, I would give it the lowest number. But it's going to change how I number these branches. So if I started to number, for example, from here, right, the beginning of the double bond will be carbon 1, so I have to go this way. If I start with 1 there, this will be 2, 3, 4, and 5. That means my 2 branches will be on carbon 1 and carbon 5. All right, now if I change that though, let's erase those. What if I did it the other way? What if I started here, and I would have to go this way in that case, because I have to include that double bond. This would be 2, 3, 4, 5 that way. Now my branches are 2 and 3 instead of 1 and 5. 1 and 5, if you add them up, gives me 6. 2 and 3, if I add them up, gives me 5. So this is a lower number for the branches because it doesn't matter the naming for the functional group. My next priority is branches. So this will be a 2, 3 dash dimethyl cyclopentene. Okay? Hopefully that makes sense. Like I said, if anything here is confusing, just send me an email or message me here and I'll try to clear it up for you, but hopefully that makes sense. The trickiest part I find in here is remembering that because there is a functional group, you have to start either here or here. But if you start here, you have to go that way. And if you start here, you have to go that way. Because you've got to start there and cross that double bond to make that the first part of your molecule when you're doing your numbering. Remembering your priorities, that functional group is more important. Then you worry about lowest number for the branches. And if that still doesn't work, then you would do alphabetical, but only as a last resort. Okay. Do a couple of these where we draw. So let's just skip into here. So if you had to draw these now, the first one gives me 2-methylcyclopentene. I find the easiest way to draw this is to just do my line diagrams for my shapes. You could easily draw in the carbons if you wanted to do this as structural. And somewhere in there I have to put the ene for the double bond. And it tells me that the branch is a 2-methyl. So I can number from wherever I want. So let's say this is 1, then this would be 2. So off that carbon 2, I would put my methyl branch sticking off like that. Now there's actually a problem with this name that they've given us here. 2-methylcyclopentene is incorrect. If you were to name this, it is a cyclopentene, but this wouldn't be a 2-methyl branch, this would be a 1-methyl branch, because I can number from wherever I want. So I can either say that this is 1 and go this way to make that a 2, or I can start here and say that's a 1 and go this way to make that 2. So I would choose the one that makes this a 1-methyl. So the correct name of that molecule would be 1-methyl cyclopentene. Okay. All right, our next example also has an error in it. So see if you can draw that one out and see if you can find the error. Maybe pause the video here and try it on your own, and then come back to see if you did it correctly. So I'll draw it out now. We've got a cyclohexane. So that's a 6-sided molecule like this one. And they've got a 2,4 dimethyl. So if I was to number this 1, 2, 3, 4, that would mean that there is a methyl group here and a methyl group here. All right, now the error in the name, remember you can number from wherever you want. So I wouldn't start here and number that from 1. That doesn't make any sense. I would start on the branch, and then I would number this way so that that gives my 2 branches the lowest possible number. There's no functional group here to worry about. So in this case, I would have a 1, 3, whoops, not a comma there, comma here, 1, 3 dimethyl, and then my parent is cyclohexane. Right? That's it for the cyclos. We're just adding in the cyclo prefix. Just be careful that it changes a little bit how you just have to think a little bit differently about how you number the parents when you do the cyclos. All right? Try the questions in the homework. If you have any trouble with any of these molecules, the alkanes, the alkenes, alkynes, or the cyclos, please let me know. Remember, this unit's just going to keep building. If you're starting to have trouble with any of this stuff now, it's just going to get worse as we go on. So make sure you ask for help as soon as you can. All right, let me know.